what's the agenda of this talk? We are basically going to cover what is software testing, then why do we need to test actually a product, what are the different types of testing, what are the skills required for to be a test engineer, what are testing environments, and where does testing fit in, like what is the role of testing in each stage of SDLC. So SDLC basically stands for software development lifecycle, the phases in which the software gets developed. So before you see a rolled out product in its full form, there are a number of phases it goes through. So we will be going through both. So let's get started. What is meant by what is testing? So basically, if you a very simplistic definition of that would be, I have some expectations in mind, and if the actual behavior of a software product matches expected behavior, it's win. Like we are trying to check by testing if the actual and the expected behavior match. But well, those are in real simple terms. In reality, testing is not that simple, and the reason behind this is that expectations never end. So you are trying to match the expected and the actual behavior, but the expectations are never ending. So take for example any site that you are familiar with, which has a very simple layout, maybe Google search that only has a text box in the website. When you see the text box, there is nothing like what is your P0 expectations as soon as you see the text box? Well, I should type in something and I should see the result for that. But once you are into it, once you are there with a bunch of results, then the expectation goes to be different. The result should be relevant to whatever I have searched for. The result should be latest and not stale. They should be relevant to my location. They should be context aware. That is, if I was searching for something like a US election in my past 20 queries in an hour, and then I search for election candidates, I should see the result for US election candidates and not and the precedence for my local elections should be taken over by the US elections. It should be like override my location priorities with the US election candidate in this case. And similarly, there are a bunch of other expectations, like the results should come fast, and then the search should be able to support a certain number of queries per second, and so on and so forth. By this, you get a brief of why is it that the why testing is a complex area in itself, because there are a bunch of expectations from any software product which might not which just by seeing the product you might not feel it. For example, if you are using a Uber app and the app takes too long to open, then then what would be the behavior as an end user? Like you would try to switch on, like every time your Uber app takes 2 minutes to load, you would just switch on to some other competitor. Maybe you switch on to Ola and you know try to book cabs with that because that works faster. The expectation of users are different, and expectations also depend upon person to person. For instance, if a blind person is using Google search, they would expect that the site should be accessible. Accessible means that you should be able to navigate through the whole site using a set of keys. The content should be read out aloud in the correct format. Testing is in itself is a very fairly complex product, fairly complex skill. We will be trying to go through like what does it require to be a test engineer. So why should we do a product testing for a product? Like why is it important? And to answer this, we will use the approach of 5 whys. So that is a very popular approach in the industry that says that if you want to know the root cause of any problem, you should try to ask why to your problems at least 5 times. So at times the answer might come in just 3 times, or at times it might take 7 times, but 90% of the times, by the time you are at the fifth why, you know the answer. So a typical example could be like you are feeling sad. So you could ask like, why are you sad? The answer could be, I got poor marks. And then the why did you get poor marks? Because I did not get prepared well for one of the subject. And why did not prepare? So like this, you keep on asking whys to the question till the time you actually get down to the problem. you will find. So companies like Amazon and Google and many big companies use this. So in such companies, the culture is not to blame a person in case of any production issue comes in or any major issue comes into a product. For example, if you might be aware, a couple of years back, the whole internet went down because someone did a misconfiguration in the Amazon web servers, and the whole of, just imagine the scale of the problem. World's internet went down, right? 40% of the world's site went down. So that's a scale of a problem. But these companies try to, whenever such problems happen, they try to find out the root cause of it and not to blame a person. And this approach is very good. So we will try to use the same approach and try to get the answer of why is testing important. Why should I test the product? The first question should be like, why do we need to test a product? Well, the simplest answer is to catch bug. Everyone does testing to catch bugs. So a bug means a defect. In industry, like we call defects as bugs. So whenever your expectation does not match the actual result, it's called a bug. It's a defect and it's called a bug. The first question is, why should I test a product? And the answer should be like, I want to catch the bugs. But then the second question comes, why do we want to catch the bugs? Because we don't want our customers to catch the bugs. Like if we don't catch the bugs ourselves, our customers will. If some company launches a product and the testing is not done properly, in the end user would catch the issues that were there in the problem. So the next why comes, why should customers not catch the bugs? Why should we catch it and rather than the customer catching it? What's the problem in the customer catching it? So the answer is like, because it can cause the customer loss of trust, loss of information, and can land the company into legal affairs. So just to understand this, what would happen if you open your mailbox one day of any provider, whatever you are using, Gmail, Yahoo, whatever mail you use, you open your mailbox one day and you find all the emails are deleted, all the content on the cloud is missing, and maybe some your storage is also blank, and it's like a loss of information, right? You had some information stored in your mail, in your drive, in your calendars, and all of them is gone. And in the same way, if the same issue happens with big companies, some other companies might be using the mail ecosystem of your client, and if they also face the similar thing, then they would definitely, like if they lose all their information because of mailing client, they would just sue them. They would file a legal case. So that could end up in a legal battle. And with all of this, what would happen is, as a customer, they will lose the trust on the company. They would not they may not be able to trust the company in the same way as they were trusting before. So the next thing that comes is, why is the customer trust and customer information so important then? So the straightforward answer is because it takes ages to build a relationship with the customer, and in some seconds only, with some major issue, some major outage, you lose the trust. So just imagine if I open my mailbox one day and I find all the mails deleted, probably I'm just going to switch to some other mail service, right? There are plenty of them. And then the final fifth why comes, why should a company not lose customers? Like that cause the customer to move away. So the answer to that would be that if you keep on losing customers, your product will never run. You will never be successful. So in a nutshell, if you see, why is it important to test the product? That the answer would be, a product that is not well tested can never be successful. So if you want a piece of software, or for that matter, anything that you are launching to be successful, you have to test it. You have to go into the shoes of the customer and understand what they want, and how is my product even fulfilling their needs, or is it just something that seems to fulfill the need but doesn't do anything actually. Then the next thing that comes is, what are the different types of testing? Earlier we had discussed the example of Google search, where a blind person comes and they want that they should be able to search. So testing of a software product for differently abled people is called accessibility testing. Like if you are testing a software product for a blind person, it is called accessibility. Or maybe someone who has a hearing disorder, or someone who is color blinded, that is called accessibility testing. So this would cover things up, like a screen reader should be able to read out the content, and for colorblind people your software should do some high contrast modes, and they should be able to use the product basically. These in a specific for accessibility. Accessibility is not something that is nice to have. Actually, accessibility is a legal requirement. If it's a law in US that the content should be accessible, and if it is not, then the government can take action against the company, and in worst case they can even turn down the product. So it is not something optional to be just like it's not it's not something that you can just take loosely. There are certifications for accessibility, and companies just hire some of the differently able people to do testing for them. With accessibility, it is a very easy to understand that it is a vector of testing. It's a dimension of testing. Under accessibility testing, there would be many others. Similarly, there is performance testing. Now, when we say performance testing, there are like performance is a very simple term to understand. Like we took the example of Uber app. If it takes 2 minutes to open the app, it's not performing well. Like it's a slow app, right? Performance is just one vector, but that is just one vector. Like there are a bunch of other vectors that there are a bunch of other testing that comes into performance testing, like load testing. How many cab requests can my Uber search serve at a time? Or if there is how much time does things take? How much server RAM usage am I taking? My product is taking. How much device RAM? How much device? What is the impact of running my application on the device battery? So all these comes under performance testing. And similarly, there are other dimensions of testing too. Like the first one would be who does the test. So that is a very there are only two possibilities of doing the test. One is manual testing, and the other is automation testing. Someone might be doing the test sitting at the desk and doing all the checking for all the expected and the actual behaviors manually, whereas you can write code that does the thing for you. They can perform some action and then match the result. Then the second vector could be size of test. In that, there would be unit test, integration test, end-to-end test, and so on and so forth. Like there could be many other possibilities of dimensions of testing. So we will cover all of these in detail in the slides to come. So let's start with what is automation versus manual testing. This is one of the long time debates on which is better, automation testing or manual testing. Let's start with what each of them means. So like I told, that manual testing would mean that you are performing each action by your own self, and automation would mean that some code does that for you. So the problem of a statement that comes into mind is that when you are doing or you wrote some code in first place for development of a software, and then you wrote some test on top of it, and those tests. So why did you write a test? Because you suspected that the code might have bugs, the software might have bugs, so you wrote more code on top of that. And by default, any code that you write cannot be bug free. So you had a buggy code and you wrote some more buggy code to test that buggy code. That doesn't make sense. Like you cannot, that's the first line of defense. Like, okay, it doesn't seem right to us in that way. So it seems that manual testing wins. Like manual testing is the answer. Then there is another problem, like automation only does what it is supposed to do. So suppose you are doing a test where you say that I want to I want to go to gmail.com, I want to fill in the username, I want to fill in the password and click on sign in. So now if you are doing that through automation, what it will do is every time it will go on the same page, it will type in just blindly. It will just go and type on that element and type the username, password, and click on sign in. And well, it says, yeah, sign in is successful. Now, what difference does happen when someone is doing that action manually versus automation is when someone does it manually, they would also see the position of the element on the screen. For example, I'm doing that on a mobile device, and the username and password fields are coming very much towards the bottom. So I would immediately say, okay, this doesn't seem right. It should have come in the center. As what would automation do is it would just go ahead and fill in wherever it is coming, because we never wrote for that thing to come on top, or where should it come. Our tests were never comprised of that. Again, that is a win point for manual testing. Like, you see everything. Example for that in favor of manual testing could be like you are doing some sort of performance test. Suppose you have an ebook and you are trying to check how much time it takes when I do right to left swipe for the page to turn. What would happen in automation testing is it would just start the timer at the start of the action and end the timer when the new page appears. It would not take into account the jitter that a user might see. For example, there is the animation which runs at this point for a smooth transition. The automation would not see that, whereas a manual tester could see. So these are points in favor of automation testing. Oh, sorry, manual testing. But then the question comes, why should we do automation testing? Why is automation testing so prevalent in the industry? So there are so many, these are some points. Yes, manual testing takes a win on all these points, but there are so many other points where automation testing would take a win. For instance, like automation testing has a very little cost to it. Like, you have a system and you run a bunch of automated tests any time of the day, and you do it how so many times you want to do. It would not, the system is not going to say, hey, I'm bored. And it is this system, the automation system is far away from fatigue and doing silly mistakes and those things. Automated system things are like blindly. It's either true or false. It's happening or not happening. It doesn't take into account those things. So those are the places where automation takes a win. Then with automation testing, you can cover many complex cases which are not possible. For example, if I have to say that you do API testing. API testing you can do manually, but if you have to do a 10,000 API testing, it won't like if you have to test 10,000 cases, automation can do all of those in parallel, and it can just keep on firing requests to the APIs and well record the responses. But for manual testing, that is going to take days and ages. So manual testing is slow. It's, despite of all the positives with manual testing, it's very slow, it's not scalable, and it has a very high cost. So that's where automation testing takes a win. With the period of time, automation testing is getting even better and better. So automation testing also has a couple of things. Like, whenever we say of automation, we talk of automation tools. So for example, if we are saying that we want to automate a website we want to automate, then the first thing that would come into mind is, what tool should I use? So there are very well-built tool called Selenium that has the capability of nearly performing every action possible on any web page. It can perform many things. It's a very well built up tool. But at times there are other cases wherein there is no very specific tool. For example, in case of security testing, you might need some custom built tools or custom built API tests that needs to fire against your against your very specific software. Like, there is no great tool which is so much known for logging testing. Like, if you want to test what is the information that my software is logging, there might not be just one answer that you could get directly. So those are the things where automation tools are made hand stitched for very specific needs. And once the tools are made, then we use one of the programming language to use the framework or the tool to write the code which does the action for us. So this is how things work. But neither of them, only automation testing or only manual testing, are the answer to the correct way to test a product. Like, we need both of them, because your automation test might be good, but you cannot automate 100%. Like, there will be some cases which cannot be automated, and for that you need people to do the testing. Let's get to the second dimension of testing, which was integration test and end-to-end test. Unit test, integration test, and end-to-end test. For understanding these testing, first we need to understand how our software is made. So how does the software gets complex? So let's take a very simple example. You have like, say, 5 numbers, 10, 20, 30, 10, 10. And you want to write a code wherein you should get the count of each of the number, like how many times 10 is coming, how many times 20 is coming, how many times 30 is coming. So in case of 10, 20, 30, 10, 10, the output should be 10 appears 3 times, 20 appears once, and 30 appears once. So this is a very simple piece of code. But what happens if you have a file of 1 GB and that contains all these numbers, and you now need to give the output? So in this case, what you would do, you can still read the file and just output the numbers, but get a bit slow. So what you can do is divide your files into 4 parts of 256 MB each, and have 4 threads or 4 instances of same program which would do the counting for you, and in their own 256 MB block, and return the result. And you can accumulate the result and display it. So that is how it would get faster. The file, now we took the instance where the file was of 1 GB. Now the file size is, say, 1 TB, wherein you cannot even open the file on your system. So the problem is different now, as the file will not even open on your system. So we need to have a distributed system, like partitioning the file into 1,000 parts of 1 GB each. And then we say that, like, we have 11 machines, so one of them become the master, and the remaining 10 of them would become slave, and master would now give out the, it has 1,000 parts. It will keep on giving each of the machine one part to process and return the result back. So now that one single machine would run the same piece of code, where it would again partition the 1 GB file into 256 MB 4 files and run 4 threads and compute the result. So now if you see, this was a fairly simple example where we just wanted to count the numbers. But when we talk of scale, when we talk of scale of a product, the complexity becomes manifold. Like, we even needed to use a distributed system for a very simple thing like counting numbers. So now comes into mind how a software is made. So when we are thinking of complex softwares, it's made in modules. Like, there could be, in this example, there could be one module which is just doing the counting. Whatever number you give it as an input, it will return you the count as output. Then there could be one part that could be doing just the partitioning of files. So if you give it any file and I expected size, it would just split the file based on the size. Then there could be another part which could be doing the threading. Like, it could run 4 threads or 10 threads. So that would be taking care of the threads. So these are the different parts that you make a code into. So that is what is called modules. So now the smallest test that we write is the unit test. So unit test has some properties, like they should be very fast, they should be hermetic and deterministic. And each test should just test one thing, like the method under test only gets tested. Like, whatever you, for example, the counting method, if you write unit test for the counting method, you should just write just test that method. You should not test where will that output go, how will that get processed. No, those are not the part. You test the smallest things first. Why should they be fast? Because unit tests are typically run every time a product gets built. Why should they be hermetic? Hermetic means, like, just test whatever you are supposed to test. So for instance, if your software product depends upon some other binaries also, so in that case, your code should test only, your unit test should only test whatever you have written. It should not test everything else around it. An example of that could be, how do you navigate on the Google map? So that's another good example. Like, if you are testing the navigate method, you should just see if I have a input is point X and Y, and I should give a path between x1, y1 to x2, y2. That's what your code should do. And it should test all the possible cases when x1 and y1 have are very far or near or whatever. So you should test those very specific very specific modules in unit test. So next comes our integration test. So this is a very nice GIF that I personally like to understand, like what is the importance of unit test and integration test. So if you see in the first animation, like there were two windows that were opening perfectly when they were alone, but you added both of them and now both of them don't work together. Similarly, there is an umbrella and that each of so in both of these examples, you see that the things were doing whatever the unit or the modules were performing their actions well. When they are combined together, they do not perform, they do not integrate well, and that's where integration test comes in. A good idea of thinking like where should I add integration test is like you should think wherever you would have eliminated the dependencies in unit test is the point where you should add integration test. The next test that comes in is the end-to-end test. So end-to-end tests are like user stories, like they are full path of what should happen when you do XYZ action. Like a unit example of end-to-end test could be like I open my Chrome and I go to gmail.com, I sign in and then I send a mail and then the other person receives it. So that is the whole user story, a user journey that you are trying to check. So that is called end-to-end test. End-to-end tests are important because they would give you confidence in system, but they are typically slow. Unit tests are very fast. End-to-end test would be slow. Also, end-to-end tests have dependency on many things. Like, for instance, you are trying to check Gmail, but you are for testing that you need to open Chrome. And what happens if your Chrome is faulty or if the latest version of Chrome has some issue where it is crashing? So because of those reasons, unit tests are end-to-end tests are very at times flaky.